Chapter 9: Dykes, Ditches and Earthworks. The modern word dike or dike most likely derives from the Dutch word dijk, with the construction of dikes in the Netherlands well attested as early as the 12th century. The 126 kilometers, 78 miles, long Westfries Omring Dijk was completed by 1250 and was formed by connecting existing older dikes. The Roman chronicler Tacitus even mentions that the rebellious Batavi pierced dikes to flood their land and to protect their retreat, AD 70. The word dike originally indicated both the trench and the bank. If you study archaeology at university or even on an ordnance survey map at length, you will notice strange earthworks on the sides of hills of Britain, with no rational explanation to why they are there and for what reason. At university, these features are mostly ignored, or an excuse is made for their construction. The reality is that these features do not make any sense unless there are other factors in operation, which have been ignored. The first thing to notice is that the word dike is associated with water. It does seem strange you would call an earthwork on top of a hill a dike, unless there was some history passed down through the years to its real use. If we look at the most famous dike in Britain, Offa, we notice that it is attributed to a Saxon king and therefore could not be prehistoric. Or is this a clear indication of how archaeologists find excuses for these features rather than true empirical evidence? Offa's dike, Welsh, cloth offa, is a massive linear earthwork, roughly following the current border between England and Wales. In places, it is up to 65 feet, 19.8 meters, wide, including its flanking ditch, and 8 feet, 2.4 meters, in height. In the 8th century it formed some kind of delineation between the Anglian kingdom of Mercia and the Welsh kingdom of Powys. At face value, this explanation seems to answer all the questions about this dike, except the water connection. But if you delve further down to look at the evidence such as findings from the dike and any written history, you get a different version, for the Roman historian Eutropius in his book, Historiae Romanae Breviarium, written around 369 AD, mentions the Wall of Severus, a structure built by Septimius Severus, who was Roman emperor between 193 AD and 211 AD. Quote, "He had his most recent war in Britain, and to fortify the conquered provinces with all security, he built a wall for 133 miles from sea to sea. He died at York, a reasonably old man, in the 16th year and 3rd month of his reign." End quote. We all know that there is not a 133-mile wall that divides England and Wales like Hadrian's Wall. All we have is Offa's dike, which its bank could be construed as a wall with ditch. So, the Romans built the dike 700 years before Offa, or did they? For we are now finding Neolithic flints and pottery inside the ditches of these dikes. So how did they get there? As we have shown on our case study on Old Sarum, the Romans are famous for taking existing features, such as ditches, and adding a defensive bank for their own use, as did the Normans who followed them sometime later in history. Offa's dike has nothing to do with Offa, but this archaeological reality or misinterpretation is the key to why our history is not as we perceive. But that is not enough to prove the higher groundwater levels in prehistory contributed to these strange earthworks. So let's look at some in our study area, where we have looked at the archaeological excavation records and constructed detailed river maps of Wiltshire in both the Mesolithic and Neolithic periods of history, to see how this feature is associated with these raised groundwater levels. Case study: Wansdyke. According to Wikipedia, Wansdyke consists of two sections of 14 and 19 kilometers, 9 and 12 miles, with some gaps in between. East Wansdyke is an impressive linear earthwork, consisting of a ditch and bank running approximately east-west, between Savernake Forest and Morgan's Hill. West Wansdyke is also a linear earthwork, running from Monkton Combe south of Bath to Maze Knoll south of Bristol, but less impressive than its eastern counterpart. The middle section, 22 kilometers, 14 miles, long, is sometimes referred to as Mid-Wansdyke, but is formed by the remains of the London to Bath Roman Road. It used to be thought that these sections were all part of one continuous undertaking, especially during the Middle Ages, when the pagan name Wansdyke was applied to all three parts. East Wansdyke in Wiltshire, on the south of the Marlborough Downs, has been less disturbed by later agriculture and building and remains more clearly traceable on the ground than the western part. Here the bank is up to 4 meters, 13 feet, high with a ditch up to 2.5 meters, 8.2 feet, deep. Dykes' origins are unclear, but archaeological data shows that the eastern part was probably built during the 5th or 6th century. That is after the withdrawal of the Romans and before the takeover by Anglo-Saxons. The ditch is on the north side, so presumably it was used by the British as a defence against West Saxons encroaching from the upper Thames Valley westward into what is now the West Country. West Dyke. Although the antiquarians like John Collinson considered West Dyke to stretch from southeast of Bath to the west of Maes Knoll, a review in 1960 considered that there was no evidence of its existence to the west of Maes Knoll. Keith Gardner refuted this with newly discovered documentary evidence. In 2007, a series of sections were dug across the earthwork which showed that it had existed where there are no longer visible surface remains. It was shown that the earthwork had a consistent design, with stone or timber revetment. There was little dating evidence, but it was consistent with either a late Roman or post-Roman date. A paper in the Last of the Britons conference in 2007 suggests that the West Dyke continues from Maes Knoll to the hill forts above the Avon Gorge and controls the crossings of the river at Salford and Bristol as well as at Bath. As there is little archaeological evidence to date the Western Dyke, it may have marked a division between British Celtic kingdoms or have been a boundary with the Saxons. The evidence for its western extension is earthworks along the north side of Dundry Hill, its mention in a charter and a road name. The area of the Western Dyke became the border between the Romano-British Celts and the West Saxons following the Battle of Diorum in 577 AD. According to the Anglo-Saxon Chronicle, the Saxons Val achieved a breakthrough against the British Celtic tribes, with victories at Bradford-on-Avon, in the Avon Gap in the Dyke, in 652 AD, and further south at the Battle of Piernam, at Penselwood, in 658 AD, followed by an advance west through the Polden Hills to the River Parrett. It is however significant to note that the names of the early Wessex kings appear to have a Brythonic, British, rather than Germanic, Saxon, etymology. I thought I should give you all the considered opinions of this dike, just to show how confused and inaccurate our history books are today. There have sadly been very few excavations, or thorough investigations of these dikes, remembering there are over 1,000 dikes in Britain. One of the earliest excavations was overseen by Lieutenant General Pitt Rivers, who excavated Dyke at Shepherd's Shaw, Devizes. Although most of the findings and accounts lack scientific accuracy, we find some aspects that support the dating of dikes earlier than current expert theories of Saxon Britain. In one of his cuttings through the ditch and bank, he noted that at one's house, there is a break in the line of the dike, which is occupied by the site of the Roman station of Volusiu, where quantities of Roman pottery are scattered on the soil. Pitt Rivers also found vast amounts of pottery and iron nails in the bank of Dyke further down the earthwork. Isn't it more likely that the Romans placed their settlement actually on the dike, as it may have still held water 2,000 years ago, and looking at the positions of the findings, actually cleaned it out, which would allow them to take and receive supplies by boat to and from the River Kennet. Moreover, he noticed that in Section 5 Stockley to Headington and by the Roman settlement in Spy Park, the river was still running inside the dike. In fact, within his excavation of the dike we noted that very little silting had accumulated on the escarp, but in the ditch, it had collected to a depth of about 3 feet in the center, showing that the main purpose for the dike was to take water like a canal. The final proof of the fact that the dikes predate the Roman invasion can be found strangely with empirical evidence from a drawing produced by the first British archaeologist William Stukeley in 1724. Where the Roman road is clearly made on and above the Dyke ditch and then cutting through the dike's bank, this is impossible to do if the bank and ditch was built after the road. Archaeologists and historians, please take note. If we look at Dyke on an OS map, to the east, the ditch ends in the middle of nowhere, just before the forest of Savernlake. The question that archaeologists fail to answer is why stop there? If you continued another 6 kilometers, you would have reached water, a natural boundary, remembering you have already cut 19 kilometers, or just turn south and that's a mere 3 kilometers. To the west it's even worse, you could go south again and connect to the river, using that as a natural defensive boundary, but no, it just stops dead. If you were to attack the ditch you would be mad, as you just walk around it as the Germans did on the Siegfried Line at the outbreak of World War II. The final proof of that the ditch is not defensive can be found in its method of construction. Going back to the work of Pitt Rivers, he produced a series of detailed cross-sectional drawings to support his investigation. These drawings showed two significant findings. Firstly, the ditch's fill was spread over both sides of the ditch, one side slightly more than the other. You would not do this if it's a defensive feature, as you would want all the high ground on your side to help defend. This kind of slightly even distribution we see on Iron Hill ditches and other featured sites such as Durrington, Stonehenge, and particularly Old Sarum. In fact, the only site we don't see this happen is at Avebury. Secondly, and most importantly, the bottom of the ditch is flat, again just like Stonehenge, Avebury and Durrington. It could also be Old Sarum, but sadly nobody has done an excavation of the ditches to date. You do not make the bottom of a ditch flat if used as a defensive ditch or a land marker, you're doubling the time it takes to make a ditch. On Pitt River's excavation plan, the flat bottom is a third of the width of the ditch. The Kennet and Avon Canal is a waterway in southern England with an overall length of 87 miles, 140 kilometers, made up of two lengths of navigable river linked by a canal. The name is commonly used to refer to the entire length of the navigation rather than solely to the central canal section. From Bristol to Bath, the waterway follows the natural course of the River Avon before the canal links it to the River Kennet at Newbury, and from there to Reading on the River Thames. Quite remarkably, Wansdyke was constructed just 3 kilometers north of the Kennet and Avon Canal. If it was a prehistoric waterway, it would have achieved the same purpose of joining the River Thames to the Bristol Channel, but some 6,000 to 8,000 years before the Victorians' Great Canal System. Now let us consider the human resources it needed to create such a structure. At 33 kilometers in length, 33,000 meters, its volume can be calculated as about 618,750 cubic meters of chalk, if it is 2.5 meters deep and 7.5 meters wide as an average. This is the approximate volume of material removed from the ditch. This is 5 times more than what was excavated at Avebury and 2.5 times larger than Silbury Hill. So, according to Atkinson's calculations at Silbury Hill, we are looking at 45 million working hours, which equates to 100 people working for 12 hours every day, 365 days a year for 102 years. It took the Victorians 100 years to build the Avon and Kennet Canal using metal tools and steam engines. Moreover, the Victorian canal was only 1.3 meters deep and 6 meters wide. The ancient canal ditch is in places twice as big as the Victorian counterparts. So, whoever built it must have spent many years in completing this task, which suggested it was essential at the time of construction. If you study a geological map of this area, you will be struck by the endless twisting rivers that once flowed on and around the Wansdyke earthwork. These are called superficial deposits and consist of sand, silt and pebbles. This is evidence that once upon a time rivers formerly flowed in these what we call today dry valleys, paleochannels, and the clue, just like the name for these earthworks, dykes, is in the title. If we add the known prehistoric groundwater rivers, based on our hypothesis, to the map of this great ditch, we find that springs would feed the ditch naturally, flooding it, and there you have yourself a canal. This 21-mile canal links, just like the Avon and Kennet, the River Thames to the Bristol Channel. And there can be only one reason for this massive undertaking: boat travel for the purpose of trade, just like the Victorian ancestors would achieve some 6,000 to 8,000 years later. However, the most miraculous revelation about these dykes is the fact that the builders had a greater knowledge of hydrology than even today's engineers and geologists, for the weakness and final demise of the canal system in Britain was the fact they were very slow. The Victorians had to build at least 1 lock per mile of the canal to keep in the water high. The Kennet and Avon have over 100 locks. The original prehistoric channel had none, as it relied on the natural groundwater table levels to fill the canal. Therefore, it was straighter and shorter in length than the Avon and Kennet, which would have allowed them to travel from the Thames to the Bristol Channel almost 100 times faster than the Victorian barges. Moreover, if you find this difficult to believe, you should bear in mind that there are over 1,000 dykes in Britain. A majority, 90%, are straight and less than 1 kilometre in length. To date, every single dike we have investigated has underground links to these prehistoric rivers created from the post-glacial flooding after the last ice age. Furthermore, some of these dikes are linked to ancient sites directly, as shown in this case study confirming the age of these earthworks. For if we add the known prehistoric groundwater rivers, as we have done with previous case studies like Old Sarum, Durrington Walls and even Stonehenge, we find out why this remarkable canal has 2 dead ends. The west side of the dike is in the middle of a prehistoric island, which perfectly cuts the island into 2, and would allow boats to sail from one end of the island to the other in the Mesolithic. At a later date an extension was added, as the water table levels dropped, to keep it connected to the Bristol Channel in the central and west section. This explains why the central section is different and straighter than the eastern section of Wansdyke and is often referred to as a Roman road on OS maps. Moreover, it proves beyond doubt that it was not built as a boundary marker or a defensive ditch, as it would have had a 6-mile gap in the middle of the earthwork. This dike was built over hundreds if not thousands of years, which reflects not only the engineering and organizational skills of this advanced civilization, but moreover, the sophistication and complexity of this trading society. Let us recap what we have learnt this chapter. 31. Offa and Wansdyke were built by the same civilization which used the raised water levels of the Mesolithic and Neolithic to sail their ships and boats from trading point to trading point. The proof of this is in the flat-bottom design of canals built in this period and the silt and water found in ditch excavations.